Okay, our analysis created. Hello to my friends, welcome to JitCat. Today we have the tips about the static analysis in Solidworks. As you see, we are in the simulation environment and I did a simple test on this shaft based on this sheet metal and I want to show you how to use the simulation in Solidworks. Okay, go to the model tab here. This is our model. Also, I put this file with the static analysis in Telegram channel. You can download it and the link is in the description. Okay, here we have a rod that's placing on this sheet metal. Okay, first you need to activate the tab of the simulation. Here we have some tabs like feature, sketch, surface, sheet metal. Okay, in the top of the SolidWorks bar we have some tabs like feature, sketch, surface and sheet metal. Also here we have the simulation. If it's deactive on your SolidWorks, it's just go to the here SolidWorks add-ins. Okay, here we have the option. I deactivated. Okay, here we have the option SolidWorks simulation. When you click on it, the simulation tab activate here. Okay, for example, if you didn't see the SolidWorks add-in, right click one of the tabs, for example here, go to the tabs and activate SolidWorks add-in. Okay, go to the simulation, tap the new study. Here you can name your analysis, for example, the static number 2. Scroll down here, we have some options here, the general simulation. We need to run a static analysis. Also, we have another simulation like thermal, buckling, fatigue, and nonlinear and others. Okay, but here we need to run this simulation static. Click on it. The new features shows you in the simulation tab. Okay, first we need to define a material from this sheet metal and this rod. Or for example, you have another components, you need to define all components in a specific material. You can directly go to the model here, the material, we can right click and edit the material and select one of the material, or also go to the static number 2. Here you can define the material. Click under this toolbar, static analysis. Here we have the two body. One of them is rod and the blue one is the sheet metal. Right click one of them, edit the material. For example, I click the alloy steel. Okay, apply. Right click, edit the material. And again, alloy steel. Okay, as you see the color change, it means the material is defined. Okay, after that we need to load a force on the surface of the rod. Go to the external loads advisor. Click on it. We have some options. Okay, the second one is force. Click on it. Here it wants us to select the face shell edge of the component. I selected this face. You need the contour of the force will appear here. Okay, scroll down. Here we have the units. SI is our units. Under that we need to define a force in Newton format. Okay, we need to push a 1000 kilogram on the surface or 1 ton. Okay, the calculation is 900 Newton. Okay, After that, we need to define a fixture for this component. For example, I push this force on the rod, and here we need to a surface to avoid the movement in y-axis. Okay, select this face, go to the fixture advisor, and here the fixed geometry, click on it. As you see, the animation shows us fixed geometric should be activated, and in this bar we need to select this face. Okay, as you see, all contours is direction into top, and hold this sheet metal, avoid the top forces. Okay, the final of the static analysis is here. Go to the run this study. Here we have the mesh. We need to create all mesh. In the mesh density, you can playing into coarse to fine. Okay, I put a little close to coarse, and it's create a mesh on these components. Okay, as you see, our mesh is created because we need to have analysis in pair of this mesh. Okay, the final process is just click run this study. Okay, our analysis created. Here is the von Mises Newton per square meter. Here the red one is the maximum of the stress, and the blue color is the minimum stress here. Also, you can find the maximum and minimum of your component is here. Right click, edit definition. Okay, go to the chart option, and you can activate show the minimum, annotation, and the maximum. It shows you the maximum where it is here, and the minimum is the corner of the sheet metal. Also, you can select the displacements. Here we have the maximum displacement is 0.1944. 1, 2, 3, and 4. This is our maximum displacement when the force loaded on this pin. Also, we have the strain here. Click on it, and it shows us the maximum and the minimum strain. Also, here you can get the reports of this analysis. Okay, here we have some columns that we need to create it in our report. Appendix is the active result summary, conclusion, study result, and others. Located, for example, in desktop, and it should be letter or A4. It's based on your location. Okay, apply it. Also, you can define the designer company or your website, or also you can put your logo and your location address and publish. Okay, our report is ready. Here, this is the complete report of your analysis. It's a good feature in Solidworks that explain all steps of your analysis, material or volumetric properties. Okay, our our static analysis is finished. I put this file also with the static analysis in Telegram channel, and the link is in the description. Join us in the Telegram channel. You can download the others CAD files. If you have any question, just comment below the video. I will answer in quick time. And don't forget to subscribe and share it to your SolidWorks guys, and thanks for watching.